This is video 4.1 part 2. We're still talking about angles in radian measure, and today we're going to be looking at drawing angles and also finding coterminal angles. So, starting with our first objective, drawing angles, you can see I have 4 different angles drawn here. Now, the first angle, if you can see it's moving in the positive direction, we're going to name this in terms of radians. This would be pi over 2 radians. Remember, we talked yesterday about the fact that halfway around the circle will be pi, so this would be half of that. And in terms of degrees, we know that's a 90-degree angle. The next one around, if I'm going around again in the positive direction, I would be going a total of pi radians, and that would be 180 degrees. Now, on the bottom, if I'm going around in the positive direction, we're going a total of 3 pi over 2's, or pi plus another half. And in terms of degrees, 270 degrees. It makes 390s. Now, I could look at this one in the negative direction. If I did want to call this a negative angle, I could call it negative pi over 2 or negative 90 degrees. They would be the same thing. Finally, all the way around the circle, this would be a total of 360 degrees. In terms of radians, hopefully you remember that's a total of 2 pi radians. These are 4 of our most common angles on our unit circle. Let's look at some more. Draw the following angles in standard position. So the next one is pi over 4. Now, remember, we're going to start always on the positive x-axis with our initial side. We're going in the positive direction, and I want to go 1/4 of pi. Now remember, 90 degrees is pi over 2, so I want half of 90 degrees, or 45 degrees, and so that would be right inside there. And now in this case, my theta is pi over 4. If I want to go 5 pi over 4, the next one over, again, we have to start in the positive direction, and I should say we want to use arrows there to help represent that angle. So we'd start on the positive x-axis, and this time I want to go 5 pi over 4. Now, as you're counting around the circle, remember that halfway around the circle is a total of pi. In terms of fourths, that will be 4/4 of pi. So we need to go 1/4 more, and that would end in quadrant 3 there. And so there is our 5 pi over 4 theta. In terms of negative 3 pi over 4, if I want to start negative, I always start on the positive x-axis, and this time I'm going to count in the other direction. Now, if we look, we could say 1/4 would be there, 2/4 is pi over 2, so it looks like 3/4 is going to end right here. Now notice this looks exactly the same as 5 pi over 4, and that's why we'll use that arrow to show we're going in the negative direction. And now here's that negative 3 pi over 4 theta. The other objective for today is finding what we call coterminal angles. Now, you'll notice that multiple angles can look the same, especially depending on how many times we go around the circle. Before we talk really about the formal definition, let's just look at these pictures for a minute. You can see in the picture, the first picture here, that we have a 60-degree angle drawn. And it looks like that, like I highlighted in yellow, and that would be 60 degrees. Now, if I take 60 degrees and add a whole circle, 360, to it, I get a total of 420 degrees. And basically what that means is that 420 degrees looks exactly the same as 60 degrees. This time I would go all the way around the circle, and then I would end 60 degrees later. Now, because 60 degrees and 420 degrees look exactly the same, the only difference is how many times we wrap around the circle. They're what we call coterminal angles. So for an angle to be coterminal, we're going to take the amount of degrees it starts with, and we're going to add or subtract 360 degrees. Now, what's the K for? It just means that it can be multiple sets of 360. So it could be 360 once, we could do 360 twice, we could do it 3 times. It's just how many times we keep wrapping around the circle. So again, those will be what we call coterminal angles because they look exactly the same. They end in the same position. So now we're going to find some coterminal angles. Again, we have to assume these angles are in the standard position. In the first one, because there's an infinite number of coterminal angles, we have to have some rules to follow, and that'll come from the question. In this question, we want to find a positive angle that's less than 360 and coterminal with the one given. So our first angle is 390 degrees. Now, in terms of a circle, which is 360, that means this is more than one circle. I want an angle less than one circle worth. So in order to find a coterminal angle in the same position, I'm going to subtract 360, an entire circle worth. And I end at 30 degrees. This tells me that 30 degrees and 390 degrees are what we call coterminal angles. Let's go ahead and look at the next example. I have 405 degrees, again more than one time around the circle. So we're going to subtract 360 and we get a total of 45 degrees. Now this is positive and it's less than 360, so that would make these coterminal, 45 degrees and 405. Now the last one here I'm going to leave you for your free response question. And I'm going to give you one hint and then you'll answer this and put it into the Google Doc. The hint I'm going to give you is that this angle currently is negative and it's negative 135 degrees. Now remember the rules of the question stated that we want a positive angle less than 360, but it's got to be positive. In order to go from negatives to positives, I'm not going to be subtracting anymore. I'm going to have to be adding. So I want you to go ahead and finish this question out and put that answer in the free response portion of your Google form, and then we'll continue with the next slide. The next slide is very similar. The directions are almost identical, but you'll notice now we're switching to 2 pi. Now 2 pi and 360 are the same thing. Really the big idea here is that we're working in radians instead of degrees. Now, right now in part A we have 5 pi over 2, and we're going to subtract a total of 2 pi. Remember we subtracted 360, that's the same as 2 pi. Now, I need to subtract fractions here. I'm going to have common denominators. So the big idea here is how many halves is 2 pi? Now, 2 pi is the same as 4 pi divided by 2. So 2 pi is 4 pi halves. So we'll go ahead now and say 5 pi over 2 minus 4 pi over 2. And when I subtract those fractions, I end with 1 pi over 2. So we had to get some common denominators before we could actually subtract. The next one, 11 pi over 4. Now, again, I'm going to subtract 2 pi, and I need common denominators. So I want to know 2 pi over 1 is how many fourths? So if I multiply that by 4, I get 8 pi over 4. 2 pi is the same as 8 pi over 4. So we'll subtract 8 pi over 4. And when I do that, I get 3 pi over 4, which is again positive and less than 2 pi, so we're okay. Negative pi over 6 is the last one. Now in this case we're negative. We need to get positive, so we're going to have to be adding 2 pi. But I want to know 2 pi, or 2 pi over 1, is how many sixths? So we're going to have to multiply by 6, and we get 12 pi over 6. So we're going to add this negative pi over 6 to 12 pi over 6. And when I do that, I end up with 11 pi over 6, which is less than 2 pi. Now, in all of these instances, we just had to either add 1 time around the circle or subtract 1 time around the circle to get to be positive and less than 2 pi. These last examples are a little bit different. And the reason, if you look at the first one, again, the same rules, positive angle less than 2 pi, which is coterminal. So coterminal angles, and we want the answer to be positive and less than 2 pi. Now, in this first example, 765 degrees, that's more than 2 times around the circle. Because of that, we'll have to possibly subtract 360 more than once. Let's start with our 765 and subtract 360 degrees. When I do that, I get 405 degrees. Now, 765 and 405 are in fact coterminal. They end in the same position. The problem is that the question wants an angle less than 360. So we're going to have to subtract another time around the circle to get, let's try that again, to get 45 degrees. So this tells me that 45 degrees, 405 degrees, and 765 are all coterminal angles. They would all look exactly the same if we drew them. The one that's positive and less than 360 would be 45 degrees. Now 22 pi over 6. So now we're dealing in radians. It's a little bit harder in radians. Remember, again, we're going to subtract because we want to be positive, and right now we're still positive, so we want to get smaller. Now, 22 sixths, if you take 22 divided by 6, you get 3.6. So we're dealing with about 3 pi here, which is more than once around the circle. Let's go ahead and subtract 2 pi. Now remember, in terms of 6, 2 pi is 12 pi over 6. And when I do that, I get 10 pi over 6. Now we can reduce a little bit and divide both the top and the bottom by 2, and we get 5 pi over 3. Now the key here is to decide, is this more or less than 2 pi? In terms of thirds, 2 pi would be 6 thirds, so it looks like we're less than 2 pi and we're okay. The final example, negative 19 pi over 6. This time we want to add because we are dealing with a negative angle and we want to get positive. We're going to have to add 2 pi, which is again in terms of sixths, 12 pi over 6. And when I add those together, negative 19 plus 12, we get 7 pi over 6. This is less than 2 pi, so it looks like we are okay there with our coterminal answer. All right, right now I want you to answer this multiple choice question on the Google Doc. You're doing the same thing. You want an angle coterminal to 10 pi over 3, and this is where we'll start class tomorrow.